In this lesson, we'll learn about proof by deduction. In mathematics, proof is basically a structured argument to show that something is always true. So, for example, all multiples of 2 are even numbers. This is a proven fact. Another thing we might have to prove is that all multiples of 6 are multiples of 3. We can also prove that. So these are the basic things. These have already been proven and now they are known facts. So now we can use them to prove further stuff. So we already know that all multiples of 6 must be multiples of 3 as well. So 6, 12, 18, 24. They all must be multiples of 3. So using that fact, we might have to prove other stuff. And when we say by deduction, it means that using those known facts to prove other stuff. So another example of a proof would be to show that the product of two odd numbers are always odd. We'll do that now. So odd numbers can be represented by 2p plus 1, where p is an integer. We have to state our conditions when we are trying to prove something. And the other value, so we need two values. So the other one would be 2q plus 1. 2q must be an even number, so 2q plus 1 is an odd number. We are using the known fact that 2q and 2p must be even numbers, and if we add 1 to it, it will be odd. Now if we multiply both of them, we get 2p plus 1 multiplied by 2q plus 1. From here I get 4pq plus 2p plus 2q plus 1. Over here, this part over here, so this underlined part, this must be even, since inside we have an integer. 2pq plus p plus q must be an integer, and we have a 2 multiplied in front of it. This must be even. And if I add a plus 1 to an even number, 1 more than an even number is always odd. So we have proven that if we multiply two odd numbers, the product must be odd. For AS mathematics, we have a variety of proof questions by deduction. Some of them are about showing that certain points form a certain shape. So I might be given the coordinates of 3 points and I might have to show that it forms a right angle triangle. So we can I can show you some examples of it. The first one is we are given 3 points, A which is 1, 1, point B which is 3, 3, and point C which is 4, 2. So these are the vertices of a triangle. So the points like this, the end points, these points are called the vertices of a triangle. I have to show that this forms a right angle triangle. If I draw this shape over here, 1, 1 is somewhere over here, 3, 3 is somewhere over here, 4, 2 would be somewhere over here. So this would be the triangle. So this is where the right angle should appear. When we have to show that there's a right angle, we have to multiply the gradients and show that it's equal to -1. So the gradient of AB would be y2 minus y1, x2 minus x1. For this case, this is x2 y2 and this is x1 y1. We'll get 3 minus 1 divided by 3 minus 1, a gradient of 1. Now we have to find the gradient of BC. When we are finding the gradient of BC, this is x1 y1, this is x2 y2. So y2 minus y1 is 2 minus 3, x2 minus x1 is 4 minus 3, we'll get minus 1. If we multiply the gradients, so gradient of AB times gradient of BC, we get 1 into minus 1, this will be minus 1. If the products of two gradients are minus 1, the lines are perpendicular to each other. So AB must be perpendicular to BC. So there's a right angle over here. This must be a right angle triangle. So this is how we prove it. We might also be given 4 points and we might have to show that this forms a square. In that case, we'll have to show that all the sides are equal and they are perpendicular to each other. So for different shapes, we have to do different things. So this is what we do for a square. We show that all 4 sides are equal in length by finding the magnitude. So if we are given point A, which is x comma y, and point B, which is p comma q, the distance AB will be root over p minus x whole square plus q minus y whole square. We can do this for all the lengths AB, BC, CD and AD, and we'll find the angles over here. For the angles, we'll do the same thing. We'll multiply the gradient of the lines and check if it comes out to be minus 1. For rectangles, we will do a similar things for the angle, but we only have to check that opposite sides are equal. And this is how we show that this is a rectangle. So if we are given 4 points A, B, C, D, I just need to show that the angle B and the angle D are 90 degree. If I show that the opposite ones are 90 degree, the other two angles must also be 90 degree if I can show that the opposite sides are equal as well. Now we can also have to show parallelogram. So for parallelogram, I have just like rectangle, but we don't have to show that the angle is 90 degree. I just have to show that opposite sides are equal. So if and for parallelogram, we have to show opposite sides are equal. So AD and BC will be equal to each other. AB and CD will be equal to each other. For rhombus, it would be like a square, but I don't have to show that the angles are 90 degrees. So for a rhombus, I just have to show that all sides are equal. So for a rhombus like this, the sides AB, the BC, all of them must be equal to each other. We can also have to show isosceles triangle. For that, isosceles triangle is basically when two sides of the triangle are equal in length. So this length and this length are equal. For this side length and this side length must be equal to each other, while the other side length will be different. And if I have to show that a triangle is equilateral, I have to show that all the sides are equal in length. And we might have to show that it's scalene as well. So this is isosceles, where two sides isosceles. This is an equilateral triangle. And finally, we have a scalene triangle. For a scalene triangle, all sides have a different length. So this is a scalene triangle where all of the sides are different. This is the longest side, this is slightly shorter, this is the shortest side. So three of them are different in length. In this topic, we also have to show algebraic terms. In this case, I am given two different equations on the left and right, and I have to show that they are equal to each other. So for example, I might have to show that x minus 2 by x cube is equal to x cube minus 6x plus 12 by x minus 8 by x cube. I might have to show this identity. So for this, I'll just break down the left hand side. We'll have x cube. We can write this down as x minus 2 by x times x minus 2 by x squared. So we can write this as x minus 2 by x times x square minus 2 into x into 2 by x plus 2 by x whole square. This is x minus 2 by x square minus 4 plus 4 by x square. We can now multiply both of them, so we get x cube minus 4x plus 4 by x minus 2x plus 8 by x minus 8 by x cube. If I write x cube together, I have x cube. If I write the x together, minus 4x minus 2x is minus 6x, and the 4 by x plus 8 by x, this is 8 plus 4, 12 by x, and finally we have minus 8 by x cube. This is equal to the right hand side, so we have proven what we were asked to show. There are sometimes questions about proofs about circles as well. So for example, I might have to prove that 4y minus 3x plus 26 equals to 0 is a tangent to the circle at, so to the circle, so x plus 4 square plus y minus 3 square equals to 100. A tangent means that it will meet the circle once. So I'll make y the subject from here. From the equation of the tangent, we'll get 3x minus 26 divided by 4. I can put that inside the circle's equation. So x plus 4 square plus 3x by 4 minus 26 by 4 minus 3 whole square equals to 100. I'll get a quadratic in terms of x. So x square plus 8x plus 16 plus 3x by 4 minus 19 by 2 whole square is 100. So I'll break down this quadratic. I'll get a quadratic in the form of ax square plus bx plus c equals to 0. From here we have to show that the determinant, or b square minus 4ac, is equal to 0. We have to do this because for a tangent, so if I have a circle, the tangent will only meet the circle at one point. So y equals to y equals to y will have only one solution. Another type of similar question is showing that there are certain numbers of roots for a quadratic equation. For a quadratic equation, if there are more than 2 roots, b square minus 4ac is greater than 0. Sorry, not more than 2, for 2 roots. If b square minus 4ac is equal to 0, it means that it has one real root. and if b square minus 4ac is less than 0, no real roots. For example, I might be given the equation kx square plus 5kx plus 3 is equals to 0, and we're told that this has no real roots. I might have to prove the values of k from here. So here I have to prove k is less than 12 by 25 and more than equal to 0. From this term I can find b square minus 4ac. This will be less than 0. K is equal to a, 5k is equal to b, and 3 is equal to c. So I'll get 5k whole square minus 4 times k times 3 less than 0. 25k square minus 12k is less than 0. From here I get, if I take k common, I get 25k minus 12 less than 0. Now if I plot this, the critical value due to 25k minus 12 will be at 12 by 25. The other one will be at 0 due to k. So this is the curve. I want the area less than 0, so below the x-axis. So I want this area over here. This lies between 0 and 12 by 25. Now if k is 0, in cases where the value of k is in front of x square, so the value in front of x square is a variable, I'll also have to consider when k is equal to 0 separately. Now when k is equal to 0, the equation I get is 0x square plus 0x plus 3 is equal to 0. So I get the equation 3 is equal to 0. This is not possible. So when the value of k will be equal to 0, I'll also have no real roots, so I can include that as well. Another topic we'd have to learn over here is the use of jottings. So for questions where we have inequalities, for example, I might have to show x by y plus y by x is greater than equal to 2 when x and y are positive. For cases like this, I have no idea where to start. So for this, I use some jottings or rough work and go from here to something I can make a statement about. So if I go over here, I can take a common denominator of xy. So we have x square plus y square greater than equal to 2. From here we can cross multiply, we'll get x square plus y square is greater than equal to this is xy. So this will be greater than equal to 2xy. I can move it to the left. I'll get x square plus y square minus 2xy is greater than equal to 0. And this is equal to x minus y whole square, which is greater than equal to 0. We know this is a fact. So that's how far we need to go. Now I'll start writing the proof. I can start with the fact that x minus y's whole square must always be greater than equal to 0. Since this is a known fact, this is a whole squared number, this cannot be negative. So from here I'll try to work backwards. So x square plus y square minus 2xy is greater than equal to 0. I'll just simply work backwards. However, over here I need to make one statement. So when we go from this line, we then divide it by xy. Now when we are dividing with xy, If the values of x or y were negative, I'd have to flip the sign. However, we are told that both x and y are positive, so I can just do this without worrying about changing the signs. So we have to state that we can use this step or this or after the step. So this step is valid because x and y are greater than 0. So x is positive, y is, sorry, this would be values. I wrote ideas by mistake. So for this, y is greater than equal to 0, x is greater than equal to 0. So x, y must be positive or greater than 0. So this x is greater than 0, y is greater than 0. So x, y must be greater than 0 as well. So we can take this step. From here we'll get x by y plus y by x minus 2 is greater than equal to 0. From here we get our first line, which is x by y plus y by x, which is greater than equal to 2. So we have proved this by using jottings. This is necessary when we cannot directly make a claim from here. We have to think for a while. So we can just calculate it reversed and start from what we are given and then write the proof down in a structured manner. So this is the case over here. So this is especially about inequality questions, algebraic inequalities, where it's not obvious where we should start from. In these cases, we just start from what we have to prove and work backwards in a rough calculation we called jottings, and then we write this down in an ordered structure from here to here, just the opposite of the jottings, to go from this fact over here that x minus y whole square must be greater than equal to 0 to come up to prove what we were intending to. Now for proof we have to learn another type of question, which is about finding mistakes in given proofs. So for example, an example question of this would be, so this is an example question of that type. So we are given a student's working and we have to find the error made. Now if I look into this working to show that x cube plus y cube is less than x plus y whole cube, we get this expression over here. The students write down that this x plus y whole cube should be greater, since we have this additional part over here which is greater than 0. Now the problem is we haven't shown that this must be greater than 0. If this was 3x square plus 3y square greater than 0, this would work. However, we have an y over here and an x over here without even power. So if y was less than 0, if x or y was negative, this expression over here might have turned out to be negative. You can look at this with an example with x equals to 5 and y equals to 10. We'll get this value to be negative, which goes against this assumption that this is greater than 0. So this is the error over here. And that's all the types of proof questions for AS Mathematics proof by deduction.